Let's solve the following system of equations we see on the screen. Is it a system formed of 3 equations and 3 unknown values? We're gonna solve it using Cross's method. For this, what we have to do is first write the biggest matrix of the system. That is, writing the whole equations, the coefficients of the equations. For the first equation, we would have the first line is 1, minus 1, 1. For the second equation, we will have minus 1, minus 1, plus 1. And for the third equation, 2, 1, and 0. V in each one the coefficients of the x, the y of the z. And the results would be 1, minus 1, and minus 1. As we can see, these are the results of the equations. Let's call this matrix 3 times 3 the matrix A. And let's calculate its determinant. The matrix A is 1 minus 1, 1. The second line is minus 1, minus 1, 1. And the third line would be 2, 1, 0. The determinant of this matrix would be minus 1 times 0 is 0. Minus 1 times 2 times 1 is minus 2. Plus this times this times this. This is minus 1 times 1 times 1. It is minus 1. Now we have the positive terms. And now let's go for the negative elements of the determinant. The negative elements are 2 times minus 1 times 1. That is minus 2. And now minus this times this times this. 1 times 1 times 1 is 1. And as this is negative, minus 1. And now minus 1 times 0, it's 0. The results of this determinant would be minus 2 plus minus 1 minus minus 2, that would be plus 2, minus 1 minus 0. And that is minus 2 plus minus 1 is minus 3, plus 2 is plus 1, minus 1, and minus 1 it would be minus 2. Let's write these results up here on the right side of the screen. And with these results, we also know that the system is compatible determined, and that means that there are 3 unknown values and 3 equations, and each value will only have one possible solution. That also means that it has rank 3, as the rank of the matrix A is 3. It would be smaller or equal than the rank of the matrix A star, but the rank of A star would also be 3. So, as I said before, this system has 3 unknown values, and for each value we would only have one possible solution. If it weren't, as I said, the system we would not be able to solve it using Cross's method. And now let's find out the result, the value of every unknown value. Let's erase everything we can. So let's begin with the x. Remember that Crossy's method is like this. On the numerator we have the matrix A star, but the column of the unknown value we are trying to solve out, in this case the x-axis column, would be substituted by the column of the independent terms, that is 1 minus 1 1. Now let's write the second column, minus 1 minus 1 1, and the third column would be 1 1 0. And the denominator, I forgot to tell you, is the matrix A, the determinant, of course. We know that the determinants of the matrix A were minus 2, and now let's find out the value of the determinant of this matrix 1 minus 1 1, minus 1 minus 1 1, 1 1 0. Using the same method as before, the result would be minus 1, minus 1, and now the negative elements would be here we go. 1 times minus 1 times 1 is minus 1. 1 times 1 times 1 is minus 1 because of the negative element, and the third element, as there's a 0 there, it would be 0. So the result is minus 1 minus 1 minus minus 1 minus 1, and that is minus 2. So the value of the x would be minus 2 divided by minus 2, and that is equal 1. We find out the value of the first unknown value, the x. Now let's go with the y. Let's erase everything down here, and for the y, the only thing we have to change is the numerator would be the matrix A, but substituting, as we did before, but with the x, substituting the column of the y, the value we're trying to solve, substituted by the independent term column, that is the last column of the matrix A star. So let's find out the value of this determinant. 1 1 1 minus 1 minus 1 1, and 2 1 0. Let's do it in another way, and what we have to do is trying to get a 0 on the third element of the second row. So adding and or subtracting rows or columns, we would have, as we have a 0 on the third element of the third row or column. So for the second row, we have to subtract the first row to the second row. It would be minus 1 minus 1 is minus 2, minus 1 minus 1 is minus 2, and 1 minus 1 is 0. And now let's solve this determinant, as it is much easier than the determinant we had previously. So we will have the 1 times this sub determinant down here, that is minus 1 raised to 1 plus 3 is 4, and that is a positive number, so we will have 1 times the subdeterminant. It is minus 2, 2, and 1. And the result of this operation would be minus 2 minus minus 4, and that is minus 2 plus 4 equal 2. So, as this determinant is 2, the y would be 2 divided by minus 2, that is minus 1. We found out the y. Let's go with the z, the last unknown value. Let's erase a little bit, and here we go. This stays the same. The denominator is still the matrix A, the determinant of it, and again doing the same process as with the x and the y, we have to write the matrix A, but substituting the column of the z, the value we have to find out, by the column of the independent terms. And now let's calculate its determinant. The determinant will be 1 minus 1, 1 minus 1 minus 1 minus 1, and 2, 1, 1. We can do it in many different ways, but I'm gonna do it again following the same steps as the previous determinant. So let's make some zeros on the matrix, adding or subtracting rows or columns, and for this purpose we'll add the first row to the second row, so we have a pair of zeros, so because it would be 1 minus 1 is 0, minus 1 plus minus 1 is minus 2, and 1 minus 1 it would be 0. Now we can choose what numbers we want to make zeros of the third row, but as we already have 2 zeros on the second row, we don't have to do it. We'll have to operate the determinant using the second row, not the first row, as I said before, as I did before, I'm sorry. And this would be minus 2 times minus 1 raised to 2 plus 2, that's 4, times the subdeterminant 1, 1, 2, 1. Minus 1 raised to the fourth is plus 1, so the result would be minus 2 times the determinant, that is 1 minus 2, and we will have minus 2 times minus 1, and that is equal to, so the set is 2 divided by minus 2 is equal minus 1. So we find out the value of the z is minus 1. We've just solved the whole system, but let me remind you that Cramer's method, as we can see, is a method that can solve nearly any compatible determined system, but as you can see, it is quite a complex process, because we have to do a lot of determinants and operations, and it's gonna take you a long time. But there's another method, Gaussian method, that is an alternative, that is much quicker to solve the problem. That is a system of equations. You won't have to do as operations as we've done right now. if you think a little bit, Cramer's method, if you have a system of equations with 5 equations and 5 unknown values, Cramer's method, it's going to drive you mad. You have to do hundreds and hundreds of operations, and for this purpose, the better method is Gaussian. I recommend you to try it and look for it on another of my videos.